topic for today will center around the transformation of functions and will involve some concepts from our last episode's topic of quadratics. Let us get started. Transformation of functions are applied when the graph of a function is stretched, moved upwards, downwards, or sideways, or reflected against the line. Three different types of transformations of functions are going to be discussed next. Transformation type 1, translation. A. Horizontal translation. A horizontal translation occurs when the function's graph is moved to the left or to the right. If we have the function fx, a horizontally translated function would have the form fx minus a. If a is bigger than 0, fx moves towards the positive x-axis or to the right by a units. Such as if we have a is equal to 3, we have fx minus 3. Then the graph moves to the right by 3 units. Oppositely, if a is smaller than 0, fx moves toward the negative x-axis or to the left. If we have fx plus 3, then fx moves 3 units to the left. This translation only impacts the x values of the function. B. Vertical translation. A vertical translation occurs when the function's graph moves upwards or downwards. Let's use fx again. When it's vertically translated, its form becomes fx plus b. If b is positive, fx moves upwards or towards the positive y-axis. If b is negative, fx moves downwards or towards the negative y-axis. If we have fx plus 3, the function moves upwards by 3 units, and in contrast, if we have fx minus 3, the function moves downwards by 3 units. This translation only impacts fx's y values. For translations, a matrix notation can be applied. If you see AB, it has the same meaning with fx minus a plus b, which means that the graph is horizontally translated by a units and vertically translated by b units. Transformation type 2, stretching. A stretch occurs when the graph of a function becomes narrower or wider. A scale factor refers to a number that you use to multiply with the function that causes it to stretch. There are horizontal and vertical types of stretching. A. Horizontal stretch. A horizontal stretch occurs when the stretch a graph undergoes is parallel to the x-axis and causes it to move away or approach the y-axis. All the x values are affected by the same scale factor. The form of fx after being stretched horizontally is fqx, and its scale factor is the reciprocal of q. If q is bigger than 1, the x values approach the y-axis. And if q is between 0 and 1, the x values move away from the y-axis. If we have q is equal to 3, you can see that the x values decrease by a factor of 1 over 3 and approaches the y-axis. If we have q equals to half, the x values increase by 2 and moves away from the y-axis. B. Vertical stretch. A vertical stretch occurs when the graph of a function stretches parallel to the y-axis and causes it to approach or move away from the x-axis. Fx after being stretched vertically would have the form pfx, and a scale factor of p when p is bigger than 0. If p is larger than 1, fx's points move away from the x-axis, while if p is in between 0 and 1, the points on the graph move closer to the x-axis. If we have p equals to 3, the function's y values become 3 times larger. The graph becomes more narrow and moves away from the x-axis. On the other hand, if we have p equals to half, the function's y values would decrease by half. Thus, the graph becomes wider and approaches the x-axis. Transformation type 3, reflection. A reflection occurs when the function is mirrored on a line, or a copy of that function appears on the other side of a line. The most common lines that a function is reflected against are the x and y axes. A. Reflection in the x-axis. If the function fx is reflected against the x-axis, all of its y values are multiplied with a negative sign. The form of fx becomes negative fx after this type of reflection, with the negative sign outside of the function, which impacts the whole function. B. Reflection in the y-axis. If fx is reflected against the y-axis, its x values are multiplied with a negative sign, and its graph appears on the other side of the y-axis. Its new form would be f negative x after being reflected. And since the negative sign is inside, it only affects the x values of the function. So those were the types of transformations that could occur when transforming a function. But what if we apply more than one of them in a question? How do we know which transformation comes first before the others? We'll take a look at this. If we combine them all, we get the form negative p f negative qx minus a plus b. If we look at this form, we can apply what we know about the order of operations. We'll work from inside the parentheses. The correct order of transformations should be horizontal stretch and reflection in the y-axis are multiplied first. Horizontal translation comes next. Vertical stretch and reflection in the x-axis are multiplied after. Finally, vertical translation is added or subtracted. Now that we know the different types of transformations and the order in which it works, we can apply them in answering last episode's quiz question. Here it is again in case you haven't tried it out or forgot what the question was. Pause the video and resume when you're ready. Let us solve it. We have fx equals to 2x minus 3 over 3. And the point A on fx lies on the coordinate 0, negative 1. And we know that gx is fx when it's transformed by horizontal translation of 3 units, vertical stretch by 4, and reflection in the x-axis. We're trying to find gx, the function of gx, and what the new point A is on gx. I would suggest substituting fx first with all these transformations before placing the actual value. So these are already in order of which comes first. From horizontal translation, we get f x minus 3. And then, by vertical stretch, we have 4 x minus 3. And from reflection, we get negative 4 f x minus 3. So this is gx, but you have to fill it in with this value first. So negative 4 times 2, put x minus 3 in the place of x minus 3 minus 3 over 3. So here we have gx equals to negative 4, 2x, 2 times negative 3 is minus 6, minus 3, so 2x minus 9 over 3. You can further expand this by multiplying negative 4, but we'll leave it like this for now because it looks factorized. Now we're going to find this new point coordinate of A on gx. So we know that on fx, A is 0, negative 1. And then we have horizontal translation of 3. We know that horizontal translation only affects the x value. So you add 3 to the x value. It becomes 3, negative 1. And then we have vertical stretch by 4 and reflection in the x-axis. They are next to each other, so you can just multiply negative 4 directly, like this, to the y value, because it's a reflection in the x-axis and vertical stretch affects the y value of a function. So multiply it by negative 4 It's not going to touch the 3, so the 3 is remaining as 3. So -1 times -4 is 4. So this is the new A coordinate point on GX at 3, 4. And that's how you solve our last quiz question. That's it for transforming functions. I hope they were easier to understand through this brief video. Next episode's topic will revolve around exponential function, which incorporates the concepts from our first video on exponents and this very video on transformations. Finally, have our new quiz question so you would know what next topic is going to be like. Thank you for watching, and I'll see you next episode.